Yeah.
Yes, and is Michael at Genesis? Was that?
Yes.
And who's at MCO? Oh, was Fatma not well?
No.
Your control of the English language is very, very notable.
I was just trying to think of the correct way, which she has some ongoing medical issues.
Oh, okay. All right.
Which.
Okay. Well, if you see her or whatever, I mean, if you contact her, just say my best wishes.
Yes.
Please. So I've got Genesis, I've got MCO, but I haven't got Silver Spring or Tumaini. Am I expecting those?
Yeah, I think you might be. Silver Spring come in late because they have a lesson.
Okay.
But they will
be here.
Okay. Shall I wait for a minute or not?
Yeah, I think so. Yeah, I think so.
Is there anybody at MCO, or is it one of their teachers?
Yes, there is the teacher Andrew.
Andrew.
Yes.
Good.
But they've been having problem with their connectivity.
I know. I'll record it anyway. Who's at Silver Spring?
Fatma is there today.
Oh, good.
Oh, is she? She's back. Okay.
Yes, she's back. Yes.
And is it Dan at Tumaini?
Yes, Dan will be at Tumaini today.
Great. Okay.
As always. Yeah.
So we got 4 today, but no Billion.
No.
No Billion, because Billion is only available on Saturdays.
Yes.
So they will use the recorded
yes.
lesson.
Okay. Well, I'll make sure that I'm recording, and then we
Yes.
can, yeah.
Genesis, how are you doing? Thank you. Thank you.
I say, Genesis, you know, in life, if you can turn up on time and be able to talk with people, you're a winner. Honestly,
they are winners, guys. They are winners.
These are one. Don't tell anybody else, but they are one of my favorite centers. Don't tell anybody else. Shh, shh.
We won't tell.
Hey, look, I'm wearing it again. Yes, Sin.
Challenge, Aide. You're our champion.
Okay. Yours is bigger, as usual.
We should take a nice photo of you with to show them that you are an advocate, to show people out there.
Yes. Yes. Yeah. Today, Genesis, we are doing Organic 2. Organic 2 because you asked for Organic 2, so we're going to do some Organic 2, but we will start with Organic 1, a little bit of Organic 1, and you will need 4 fingers, well, up to 4 fingers, because you're going to vote.
So you don't need a thumb today.
Shut up. You are so funny.
Right, I'll go away.
No, yeah, well, you can, but I mean, yeah. Fatma's here. Hey. Guys, while we are waiting just for a minute, if you are going to write down things, if you are going to write anything down, it would be worth getting a piece of paper. And oh, look, MCO, they're nice room, but no kids. Hey, well, good. It would be worth this. If I hope you can hear me still. I know you can see this. What I think it would be worth you writing down is very simply, I'll just make this a bit smaller. Come on. Alkane, whoops. Alkene, alkanol, alkanoic acid, and then up here polymer, and down here ester. Okay, these we will be connecting these, so this is worth having on your piece of paper, because we will be drawing arrows from one to another and so on. Okay, we will be drawing like arrows from here to here and from here to here and so on. So to start with, it would be worth you writing alkane, alkene, polymer, alkanol, alkanoic acid, ester here on your piece of paper, because we will then use that several times. There are some arrows which we have to put on, but don't worry about the arrows yet. Okay, I will put the arrows on. So all we want is that to start with. Okay, so if you want to just draw that now, that will help in a minute. Okay, now MCO are coming in, which is good. Hello MCO, very nice to see you. I hope you can hear me. Good, excellent. I like the thumbs up thing. People are very keen to do the thumbs up. I hate them. Fatma, it's really good to see that you're okay, I hope. So we're still waiting for Dan, aren't we? Tumaini, but we'll get going. So if you're going to write down anything, this would be useful just now, because before I start, this is how we are going to be planning our thinking. Okay, we are going to make some notes and some bits and pieces, and this is how we will start. Okay. I'm going to stop sharing that in a minute. Don't worry if you haven't got it. If you do not have it, do not worry, because there will be more chance, but this will save some time. If you have alkane, alkene, alkanol, alkanoic acid, ester at the bottom, and here polymer. Okay. All right. Okay. So, okay, guys, let us start. Oh, Silver Spring. Good. Excellent. Okay, hello. I'm sorry I've been away, but I'm back now, and I am ready to teach you some chemistry. I'm recording this, so if your Wi-Fi, if your connection drops out, do not worry. I will send it to the supervisors. The supervisors also have a copy of the PowerPoint I'm going to use, the presentation, and 2 sets of questions. And the questions, I'm going to send the questions to you as an assignment. Do as many as you can. I will then send all of the answers to the supervisors so they can show you the answers. Okay, everything. Okay, so we're going to do organic 2. You know, organic 1 starts alkane, alkene, alkyne, that. Organic 2 is much more difficult. And most of the KCSE questions in the examination are to do with organic 2. So what we're going to do is I'm going to just start with a little reminder of organic 1, and then we're going to go into organic 2. Okay, so here we go. I'm going to do it via a presentation, but I will every so often I will stop sharing and see if there are any problems. So let's go. Let's hope it's okay. So here we go. So I'm going to share this. And hopefully you can see that. So this is what it's all about, but we're going to start with some stuff from Organic Chemistry 1. And what we want to do is to start with the type of reaction. So it's important that, you know, don't bother writing anything down now. Do not write, just think, okay? The type of reaction is how we would describe that reaction, not the chemicals we would use, but what we would say about it, okay? So this is what you have basically drawn already if you have written it out, okay? We have just the same as the other thing I showed, alkane, alkene, polymer, and alkanol here. This is just organic 1, okay? That's all. Okay, so here we go. So I find it useful to have a visual, a picture that is part of your revision. If you have pictures, you will remember pictures. If you have room wherever you live, if you have a picture like this, or the one when we have finished, if you have that one, then it will be very useful because you stick it on the wall and you see it often, and that will help you remember it, okay? It's very important. So here we are. What we're going to do is we're going to talk about the type of reaction that helps us here to see these. So here we go. Now, when you have a visual picture, what you want to do sometimes is take some of it away. So that's what I had. I want to try and remember the places where these are, because when I fill in the arrows, then I will remember all of it. So in revision, try to have a picture. So what is here? Oh yeah, this is alkene. What is here? This is, so you try to remember. Okay. So what are the types of reaction that we have? Well, so I want to look at this one. Alkene, they have a double bond and it goes to alkane. How do I do this? What is this type of reaction? This is a very common question. What is this one called? This type of reaction? And then we want to know what this one is, what this one. So the very first one, just try to remember for yourself, just try to think, what kind of reaction is this? And I will tell you that this one is hydrogenation or reduction, okay? Now, on your diagram, you might want to write that. But if I were you, I would do this. I would number them, okay? So there is no need to write that there. No need to write it. It's a bit sideways. It doesn't matter. This is called reduction. From alkene to alkane is reduction. It is also the addition of hydrogen, which we call hydrogenation. It's hydrogen and then ation, okay? This one, from an alkane to an alkene, this one is cracking, okay? This is when we take long carbon chains and turn them into short ones and alkenes. That's very important. From an alkene to polymers, this is polymerization. You need to know this word. Polymerization is just joining together many small molecules to make a long chain. Many small molecules make very, very long ones. I hope you can see this big enough. I could make this smaller, but okay. So this here, I hope you can see, is polymerization. And this one here, from an alkene to an alkanol, this is called hydration. This is addition of water. Okay, addition of water. from alkene to alkanol addition of water. Okay, so let's go back. What you do is you try to go, aha, what is in these different places? So you try to ask yourself the question. This is the way to revise. You cover up your map. You make your map and you go, okay, down here is, oh yeah, yeah, I think it is, what is it? Oh yes, this is it. Alkene, alkane, polymer, alkanol. What are the arrows? The arrow, this one is, yes, reduction, this one cracking, this one polymerization, this one hydration. These are important ideas that you can then focus on when you are trying to remember. Now, this is all Organic Chemistry 1. So this is relatively straightforward. You may not remember it, but that is what it is, okay? Now we're going to move on and to try to remember the chemicals and the conditions. It is very often the case that you have to remember the chemicals, okay? The chemicals themselves, what chemical is there? And the conditions is, do I have to heat it? Do I have to put it under pressure? Do I need a catalyst? I don't know. So I have to try to remember those, okay? So let's have a look at them. So again, this time now we are going to try to change the chemicals. So here they are. How do I make an alkene into an alkane? How do I make an alkane into an alkene? How do I make alkene into alkanol? This is the bit that you have to remember. And you'll see at the end of the whole of this morning, this afternoon's lesson, you will see a question which works like this. Okay, so the question is, what are the reagents? That is the chemical. This is a name, this is a word that they sometimes use in the KCSE. This is the chemicals. Conditions is whether I need to heat, okay? Or add a catalyst and so on. Okay, so from alkene to alkane, we need hydrogen. Look, I have colored here, hydrogen. You get a copy of this. But this hydrogen, that is the reagent. The conditions are a nickel catalyst and 60 or 70 degrees Celsius, okay? So this is something you need to just remember. H2, Ni, 60, 70 degrees, okay? You just have to remember it. So what you do is you test yourself. You say, how do I do this to here? Yes, hydrogen, nickel catalyst, 70 degrees. Okay, so how do I do an alkene to a polymer? I have to use pressure and heat and a catalyst. They do not ask you, KCSE, do not ask you for a catalyst. They are very, very odd catalysts, but it needs high pressure, very hot heat, and a catalyst. And alkene becomes polymer, okay? Same thing. When you are revising, you just go back, you go, okay, I cover this with my hand. I go, I can't see this. And I try to remember, yes, pressure, heat, catalyst. Alkene to alkanol, there are different ways of doing it, but the industrial way, we use water. So it's alkene and water, and it is steam. So it is H2O, but because it is 300 degrees Celsius, these are numbers you have to just remember, 300 degrees Celsius, a pressure of 70 atmospheres, that is 70 times more pressure than in your room today. And this is phosphoric acid. They don't mind if you write H3PO4 or phosphoric acid, doesn't matter. Phosphoric acid, it could be sulfuric. It works the same, okay? Okay. All right, so again, what you are doing is you are making a list and then you test yourself by removing them and going, no, how do I do this one? How do I make, how do I do this one? And so on, okay? So you cover it up and then you have a look and see if you can remember, okay? All right. The next thing from chemistry 1, organic chemistry 1, is this. The two bits are names and isomers. Okay, so names and isomers, this is all chemistry 1. Can you remember the names of the ones that you come across in chemistry 1? And can you remember what isomerism is, or what isomers are? So here we go. The names, firstly, of alkanes. Now, don't write all this down. It is a waste of time, okay? It's a waste of time to write everything down. Somewhere you probably have this anyway. Here is a table. But what I want you to do is just to remember this. This is rather stupid, but I want you to remember MEPB. So most elephants, elephants prefer bananas. Now this is stupid, yeah. This is childish. Doesn't matter. The point is to try and remember MEPB. Okay, that's very important to try and remember that. Okay. Whoops, I can't rub it out. Oh no, why is this not rubbing out? Oh dear, I can't rub it out. That's a shame. Oh well. So next bit. So here's my table. Don't worry about this. MEPB. Remember the order, MEPB. Because this is where it is. Look, here we are. Meth, F, prop, bute. And after that, it is easier because you know the mathematics, you know the shapes. Pent, okay? Pent, hex, hept, oct. Those are like pentagon, hexagon, and so on. And what is important about that, what is important about this, meth, eth, prop, bute, pent, is that that starts all of them. So the alkanes, all single bonds, 1, 2, 3, 4, 5 will be pentane. When I come to the alkenes, it's exactly the same sort of thing. There is no methane because all alkenes have carbon-carbon double bond. Because they have carbon-carbon double bond, you need 2 carbons. So there is no methane. That is quite important. I tell you why that is important. That is important because if they ask you for, and it sometimes has come up, if they ask you for the 3rd member of the series, if it was the 3rd member of the series and the alkanes, then it goes methane, ethane, propane is the 3rd member of the alkanes, but the 3rd member of alkenes will be ethane, propane, butene. Ah, okay. So alkenes are the ones with double bonds, okay? So anything with a double bond, that's an alkene. So it's exactly the same system. It's like a first name and a second name. Ethene, propene, like the ones which were the alkanes, propane, propene. And then we come to the alkynes. The alkynes were the ones with triple bond. These ones here. Just count the carbons, 1, 2 carbons, ethine. 1, 2, 3, propine. They don't all have to be triple bonds, there just has to be one in the molecule. Okay? So alkanes, single bonds, alkenes, double bond, alkynes, triple bond. Okay? Simple stuff. Last bit of chemistry 1. These 2 molecules have something in common. They have something in common, and the something in common is that they have the same number of carbons and the same number of hydrogens. This here, we have come across in the naming. This is 4 carbons, all single bonds, so it is an alkane, okay, an alkane, and therefore this is MEPB, butane. These two are similar because they are both C4H10. C4H10 is this and this, but these two are different because this is what we call a drawn out formula or a structural formula. They mean the same thing. When they draw out the bonds, sometimes you have to draw them out. When you draw these out, just remember each carbon has to have 4 bonds. Okay, very important, 4 bonds for each carbon. So however I draw it out, I have to draw it out with 4. Okay, so these two have the same molecular formula. A molecular formula just tells me how many carbons, how many hydrogens. But the drawn out formulas are different. These two are called isomers. Isomers. Sometimes they show you different molecules and they say, are these isomers? And what you do is you count. So I start with this one over on my left and I go C, 1, 2, 3, 4, that's C4, H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Then I look at this one, C, 1, 2, 3, 4, C4, H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, they are isomers because they are both C4H10. Okay. Now, before we go to organic 2, I want to ask if there are any questions. I want to ask if there are any questions before I test whether you have learned that. Are you ready? Are we ready? Don't go to sleep. Don't go to sleep. Wake up, wake up, wake up. Come on, Silver Spring. Oh, Silver Spring is so tired today. Hey, MCO, nice to meet you. Very nice to meet you. Well done. And I understand you have teacher Andrew with you, which is very nice to meet. Thank you. Right, guys. So here we go. I'm going to share a screen and we're going to see if you can answer these questions. So here we are. Let's get up here. Come on, share. Okay, so what I want you to do is you have to show me the number of fingers that you think this is. Okay, so if you think when I ask about chemical A, you have to decide whether chemical A is an alkane, an alkene, an alkyne, or an alkanol. If you think it is alkane, you hold 1 finger up. If you think it is alkene, you hold up 2 fingers. If you think it is alkyne, you hold up 3 fingers. If you think that is alkanol, you are an idiot. But you hold up 4, okay? Don't hold up 4 for A. Okay, so what I want you to do, please, is I want you to look at chemical A. Okay, that is an H. I just, with my funny hand, I can't write very well. So is this an alkane, alkene, alkyne, alkanol? Okay, 1 finger, 2 finger, 3 finger, 4 finger. Hold up fingers, guys. Hold up fingers. I'm looking at you on the other camera. Most people are giving me a victory sign. That is a victory sign. Yes, this is 2. This is good. That's good. This is, okay, this is an een. So this one, most people get a smiley face. That's very good. Okay. The second one, this one here. This is CH3, CH3, CH3OH. Okay, is that alkane, alkene, alkyne, alkanol? 1, 2, 3, or 4 fingers. 1, 2, 3, or 4. Come on, Silver Spring, get courageous. Come on. We got some people with some hands up. MCO are holding 1 finger up. Fatma team, Fatma are holding up 4 fingers. Silver Spring, 4 fingers. Genesis are not entirely sure. Yeah, they're 4 fingers. It's 4 fingers. It's 4 fingers because of this. It is important that you spot this. Look here. That there is an O. Alkanols have oxygen in them. Okay, 1 oxygen makes it an alkanol. So for Genesis, for Silver Spring, for Tumaini, 4 fingers, very good. MCO, oops. Okay, here we go. Here is the next one. All right, make it a bit bigger. Whoops, hello, wrong way. Okay, this one here. Now you have to think a little bit now. You have to think. Remember what I said about the number of bonds? Because I haven't shown this drawn out, is this alkane, alkene, alkanol, or alkyne? What is this? You have to think. If you want, draw it out. In a minute, I will draw it out. But to start with, what do you think? 1 finger alkane, 2 fingers alkene, 3 fingers alkyne, 4 fingers alkanol. Come on, guys, get brave. Let's get brave. We got some people, we got Silver Spring, we got somebody with 3 fingers up, 2 fingers with, 2 people with 3 fingers up. Oh, come on, Tumaini. Come on, Genesis. Come on, MCO. Start getting courageous. Come on. Is that alkane, alkene, alkyne, alkanol? Well, you know it is not alkanol. We've got a lot of people with 3 fingers now. Silver Spring, very 3 fingers. Genesis, 3 fingers. Let's have a look. So if I start to draw it, oh, wrong pen, sorry. If I start to draw this out, if I start with this carbon here, I have 1 carbon and it only has, oh, do not do that. It only has 1 hydrogen on it. Then the next carbon there, and then the next carbon here, and this carbon has 3, ooh, don't. This has 3 hydrogens on it. Now, if I have to draw all the other bits, I know there will be 1 line here. This carbon now has 1, 2, 3, 4 bonds. This one has 1. Oh, we need that. So those of you with 3 fingers up, which was all a Genesis, all a Silver Spring, very, very good indeed. That is an alkyne. Well done. Okay, let's have a look at D. Very good. Everybody see that? See how we draw it out? Let's have a look at D. Let's have a look at D. Here is D. Let's make it a bit bigger. There it is. Have a look at D and decide whether it is alkane, alkene, alkyne, or alkanol. Fingers. Draw it out and fingers. Okay, ready for fingers? Okay. Oh, Silver Spring having a bit of an argument there. Good. Okay, everybody. You have to put up your hands with the fingers ready. 3, 2, 1. Fingers. Fingers. Come on. Come on. Silver Spring says 3. Genesis say they haven't got any fingers left. Oh, we have a 2. Okay, we have argument between Silver Spring and Genesis. Who is right? Fatma, you've got 4, 5, 17 fingers there. That's very good. Okay, MCO, don't be cowards. Is this 1, 2, 3, 4 fingers? Come on, MCO. Come on. Silver Spring seem to think 3. Okay, I'll draw it out. Here we go. So I'm going to move it up a bit. So here we are. That carbon there has 3 hydrogens on it. Okay. It is joined to this carbon, which has 1 hydrogen on it. It is joined to this carbon, which has 1 hydrogen on it. It is joined to this carbon, which has 3 hydrogens on it. Which carbon is missing some bonds? These 2. Ta-da! So those of you with the alkene hand with 2 fingers up, you were right. Well done. Okay, so now we will move on. Now we will move on back to organic 2. So I will go back to share. Is that okay with everybody? Everybody, you learn your fingers. In the exam, you won't need to hold your fingers up. You have to write it down. If you're standing there with 1 finger up, 3 fingers, yeah, victory. Careful. Okay, very good. Well done. So now I'm going to share. We're going to go on to organic 2 now, okay? The same sort of thing, but we are going to look at what alkanols are, what alkanoic acids are, and then we will move through the whole thing. Okay, here we go. Okay. So this is organic 2. And now we're going to move on to the bits which are most important, and that's alkanols. Now, you may want to write this down, but you get a copy of this PowerPoint, of this presentation. So if you want to just watch and listen, that is sensible. If you know, when you are writing many things down, you cannot listen at the same time. So if you want to write, that's fine. Or if you want to write it later, that's okay. So the important things to know about alkanols. Firstly, they have OH. Sometimes this is written just OH, like at the top here. If I write OH here, whoops, sorry, hang on. Here, we can write it like this, but if we show a drawn out formula, it has to be O and then a bond to the H. Their general formula is CnH2n plus 1 OH. Now this allows me to work out the formula. Whatever n is, let us say we are 2 here, then this is 2 times 2, which is 4, and 1, 5. So it will be C2H5, but they all have OH. Okay. And they have a set of uses. You need to know what they are used for. They are used for fuels. In some countries, like Brazil, Brazil is very, very short on oil. So they use it as a fuel. Teacher Andrew, you have your hand up? Or are you just saying that's okay? Teacher Andrew, can you?
I'm around.
Are you okay? Oh, that's okay. Okay, good.
Yes.
So the things to remember, they have OH. This is their general formula, and they are used for fuels, solvents, that is for dissolving things, for dissolving things like paint. They make pharmaceuticals, that is drugs, like aspirin, and they make esters, which are the very sweet smelling chemicals, okay? All right. So here are some alkanols. Here they are. And look, the same, this is the, most elephants prefer bananas, MEPB. Look, it's exactly the same. If it's 1 carbon, it's meth. If it's 2 carbons, it's F. If it's 3 carbons, prop. If it's 4 carbons, it's but. But it's methanol, ethanol, propanol, butanol. Okay, so the alkanols are like this. Note that we often write them with the OH at the end. CH3, OH, C2H5, OH. This could also, ethanol could also be written as the separate carbons, CH3, CH2OH. So both are correct. It doesn't matter. Okay. These are their formulas of the simple alcohols. The most important of all of them is ethanol. It is the one which is easy to make. Many people make it across the world. In fact, probably it was the first chemical ever made by humans in large quantities. We think that people have been making ethanol for around about 15,000 years. We haven't been making anything else that long. So it is because we enjoy the taste of it, which is not necessarily very good for us, but we do. So alkanols, this is the alkanol family, what we call the homologous series. If we go back 1 page, I'll come back to this one. If we go back 1 page, this is called the functional group. The functional group, it's what makes them behave as they do. So there they are. Okay, there's the alkanols. Now, the next thing we need to know is how we make alkanols. And there are 2 different ways of making alkanols. If we concentrate on making ethanol, the first one, I'm sure you know, the first one is fermentation of sugar. It is really, really easy. You just start with some sugar. And if you take sugarcane, crush it up, you need some yeast and some water. And you need a temperature around about our blood temperature, around about 37. in many of the KCSE notes that you will get from some schools, they will say 40. What is important? It is not too cold and not too hot. If it is too hot, it kills the yeast. The yeast can only take temperatures up to about 42 degrees. So go for 37, 40, that is fine. Okay, that's really good. If it is too cold, the yeast goes very slowly and it takes a long time. What is sometimes asked is you have to remember it's anaerobic. In other words, no oxygen. If you have oxygen, it goes bad. It doesn't make alcohol. The second method, so you need to know this, fermentation of sugar, and you have to know that name, fermentation. The second one is what we call hydration of ethene. Hydration means addition of water. The word hydration means addition of water. If we start with ethene and we add some steam, we've come across this already. We have steam, in other words, water. We have come across this. Try to remember the numbers, 370. If you can remember this, and you remember it is steam, then you know the 300 must be the degrees Celsius. Because if it was the other way around, if this was the temperature and this was the pressure, it wouldn't be steam, right? So 300 degrees Celsius makes it steam, 70 atmospheres, phosphoric acid catalyst. It is also used using a sulfuric acid, a sulfuric 6 catalyst as well. Both ways are very good, but this one is very small scale. If you go and you look at a brewery, you would think this is big scale. It is very, very small scale for a country. In Kenya, this is made quite a lot. There's quite a lot of beer made, but in terms of volume made, it is much smaller than this one. This one here is normally for a country about 1,000 times as much as this. So you make hundreds of thousands of liters of this or gallons of this and millions of liters this way. Okay. Have we got any questions? I'm going to stop sharing. So I'm going to stop just for a minute, see if there are any questions which people have about alkanols so far. Any questions so far? Anybody got a question that they want to raise? Or if you're okay, just go, hey, and I'll go, I like this with look there. We're okay. Good. Excellent. Okay, I continue. Okay, we're going to continue now. So now we go to alkanoic acids. The alkanoic acids, you come across a lot in nature. They are very common in nature. Many plants and animals use them for weapons. They use them to hurt us, to kill their prey, to stop us eating them, and so on. Okay. So alkanoic acids, firstly, they have, oh, hang on, what's happening here? We are looking for COOH. COOH. Now, what you have to remember is that it is not in a line. So actually it is, oh, no, come back. It is actually like this. A double bonded oxygen and a single bonded oxygen with a hydrogen. In other words, it's not COOH. It's not this. Okay, it is this here. That looks like a heart. It isn't meant to. So they have COOH, all right? So their general formula is CN H2N plus 1 and then COOH. Okay, CN H2N plus 1 COOH. I'm sorry about the ink. I can't get rid of the ink at the moment. I don't know why. Oh, yes, I can. Good, I've got it. That's better. Okay. So that means that you have COH, and if I have 2 here, if N was 2, then it is 2 times 2, which is 4 plus 1, C2H5COH. But when we come to naming them, we have to count all the carbons, including this one. Okay? They are used as many things. They are acids first. So when you have, if you boil water and the water is hard water, you get chalk in your saucepan or your cooking pot or your kettle. You get lime scale. And we use these acids to remove them, because alkanoic acids are not very strong acids. They do not dissociate completely. They are weak acids. And they are used, like the alkanols, to make things like pharmaceuticals and esters. Okay, we make many things from them. Okay, so the important things: COOH. This here, you will recognize it. You will not be asked what this is, but it will help you spot it. You will be able to see one and go, oh yeah, I get that. I see that is an acid, alkanoic acid. Okay, so here we go. Here are some examples. Okay, so the first one, is no carbons apart from this one here. So it's COOH with 1 hydrogen. So the simplest acid you can have has 1 carbon. And because it's just 1, like methane or methanol, it is meth. And this time they end in anoic acid, methanoic acid. It's in ant bites. If you've ever, of course, you've been bitten by ants. When I was a child in Nigeria, I was bitten by hundreds of ants once. I never forget it. They inject you with a little bit of what we call formic acid. It is called, its old name is formic acid, because the word formos means ant in an old language called Latin. This one, look at this. This is important, that you are trying to spot the 2 carbons, okay? It is very tempting to call this meth because you think, oh, it's only got 1 carbon here, but it's got 1 here too. So that's 2 carbons, so it's F, okay? So you count all the carbons in the chain, okay? That's very important that you spot how many there are. So I'll just get rid of those there. So ethanoic acid, this is vinegar. This is bad wine. If you get wine or beer and it goes off, this is because it is left in the air, this is vinegar. Then we have propanoic acid. I'm just showing you it. You would be able to work out butanoic acid. Butanoic acid would have this COOH and 3 carbons here. Okay? All right. Now, let me just see if I can get rid of that. Nope. Okay. When a glass of wine or beer goes sour in air, this is because it is turned into vinegar. Vinegar is French, a French word. It is vin, like wine. Aigre means bad, so it means bad wine, vinegar. So when it goes bad, what is happening is that the alkanol is turned into the alkanoic acid. This is an equation which you need to know. You need to be able to work it out. Now, this is how we write oxygen from an oxidizing agent. And the oxidizing agent is potassium dichromate. Okay, so that is potassium dichromate. And you need to know that it is an orange color to start with. And when it reacts, it goes green. Okay, so when it oxidizes the alkanol, the oxidizing agent goes green. It starts out orange, you heat it up, and it goes green. And we need a little bit of acid as well. So we normally add a little bit of dilute H2SO4, dilute sulfuric acid, okay? And that turns the alkanol into the alkanoic acid. Okay, alkanol, alkanoic acid. It is balanced by having 2 here of these. So the O in square brackets means oxidizing agent. Important that we don't try to write potassium dichromate is, oops, come back. Potassium dichromate is K2Cr2O7. We don't write this in an equation. Okay, we don't write that in an equation at all. Get rid. Okay, so potassium dichromate is the oxidizing agent. So what do you need to be able to do? Well, you need to be able to write this equation here. So ethanol, 2 carbons, C2H5OH, plus O goes to CH3COH. And look, this has 6 hydrogens, this only has 4. And therefore we have water formed as well. Okay. Okay. Any questions? Because now we're going to go into a little bit further. Are we okay? Are we still alive? Still alive? Mostly alive? MCO still alive? Silver Spring, only 2 people still alive. That's a shame. Bad luck. 3 people. Okay, good. Genesis are always alive. Genesis are like, these are the guys who are going to be on time. They're going to be running the train system because they are always on time. The train system, the bus system. When I was last in Kenya, just like the UK, train system was rubbish. You wait for a train, you give up, you walk. Maybe it's wonderful now, but if Genesis is running it, it will be really good. Okay, so here we go. I'm sure MCO, I'm not saying you're not brilliant. I'm sure you're brilliant as well. You can run the bus system, easy. Silver Spring, you can run all the restaurants because you look hungry. Okay, here we go. All right. So now, this is the bit where it gets a little bit more complicated. If you remember, we started with alkane up here and alkanol, and there was something here and something here. And what I'm going to do is I'm going to show you the rest of this picture. But this is the way you test yourself. You write alkane and you go, what is here? What is here? No. And you can't remember. And if you can remember the whole picture in just a minute, you will find it makes life much easier. So let's put the other bits in. Oh, yes, alkene, polymer. Yes, I remember. Now we're going to add some more bits. So this is the industrial way of making alkene into alkanol. What can I make an Oh, I don't know this. Okay, so here are some other bits. Yes, I can make an alkanol from glucose. That's from sugar. Okay, what is the name of this? Yes. Okay, so I'm now going to reveal all of it bit by bit. This was yeast and water and warm. But an alkanol can be turned using an oxidizing agent with some sulfuric acid and heating it into alkanoic acid. If I take an alkanoic acid and an alkanol and I add them together, if I add those 2 together, the alkanol and the alkanoic acid, I get an ester. An ester is a very sweet smelling. It has a very pleasant smell. If you smell a ripe banana, if you smell a ripe pawpaw, if you smell those smells are esters, okay? Okay, now, this is what you need, this here. So we've already got this part of it here, over here. So what I'm going to do now is I'm going to ask you to add the other bit. So alkanol is made from glucose. So glucose, you need glucose, turns into alcohol. This was called fermentation. From an alcohol, if it is oxidized, this is oxidation here. The oxidation makes it into alkanoic acid. And the last bit is that alkanoic acid and alcohol added together make this ester. Now the alcohol was ROH, the alkanoic acid RCOOH, and this is RCOOR, okay? It is COOC. I'll give you just a moment just to write that down if you want, okay? When you have, if you've written anything down, if you've had enough, just put your hand up to show me you're okay, you've got it. Genesis, you okay? Cool. MCO, are you okay? Oh, poor old Genesis are frozen. Silver Spring, are you okay? Cool, excellent. Now, many esters are natural, okay? So esters are natural, and these are oils and fats. And if we take those, we can turn them into, using an alkali and heat, we can turn them into soaps. Okay, so esters turn into soaps. All right. So this is the basic pattern, and this is something that you would do and you would test yourself. So you would go, okay, I have that. Now I'm going to cover it up. Oh, no. Oh, can I complete it myself? Okay. So you would think, can I put what is here, what is here, what is here? Because if you can remember all these, it will be much easier. Okay. So here is a real question from KCSE. This is why we are doing this particular process. This is why we are trying to remember this. One of the most important things you do in an examination is to be cool-headed. You have to start somewhere and you have to think, I can do this, I can do this. I will focus on one thing at a time. I will not get confused by this. So if I think, okay, I'm going to start somewhere in this particular thing, I'm going to start here. Whoops, hello, what's that? I'm going to start here. Okay. I'm going to start there because I can go, I know that is C2H5OH. Now, I remember from my diagram that this is an alkanol. Alkanols are made from glucose via, I know this is fermentation. I know this is fermentation. So I concentrate on just one small bit. I do not try and do all of it at the same time. Okay, very important. So I know I start writing down things so I do not forget them. Okay. Now, process, what is this? To make crude ethanol into pure ethanol, you should know that this is distillation. Okay. It's actually called, oh, don't do that. It's actually called fractional distillation. Now, I'm going to, very soon, it is time for the end of the lesson. And I'm going to leave you with these questions, but I will also send to the supervisors all of the answers, okay? All of the answers. So here I have ethanol. This is my alkanol. If I have remembered my picture, then I know that when I add, that is acid, MnO4 minus. Now you should know that that is permanganate. Okay, that is permanganate. That is an oxidizing agent. If it is an oxidizing agent, I know what B is going to be because alkanol, I remember from my picture, alkanol oxidized. This is alkanoic acid. B is an alkanoic acid. Now, alkanoic acid plus ethanol, this is an alkanol. Oh, alkanoic acid and ethanol. This must be ester. Okay. All right. Do you see, by concentrating on only one small bit at one time, you can do it. Let's start again back here in the alkanol. Concentrated sulfuric acid 100. This is dehydration. If you look back at the list, if you look back at the map, you will find that it is on there. And if I take ethanol, the alkanol, and I do this is dehydration. And it makes this is an alkene. If it's if this is ethanol, this will be ethene, okay? Process M. Wait a minute. From ethene to ethane, I know, get back. I know this is hydrogenation. This is hydrogen and nickel and 70 degrees Celsius. I remember this. So if, in other words, this is a really, really big question. You will see it when you get the questions given to you. This is a huge question. It has many, many marks. But this is all really basically just chemistry 2. And all of this whole thing comes from just very simply the first thing which we were doing. I'm going to leave this for a minute. You will get it afterwards. So if you go back to the original picture of let me just go back. If you go back to this, if you can learn this, you can do one of those big, big, hard questions. I promise it's simple learning. It really is simple learning. All of that came out in this question here. Everything, all of these points here came from that one map, which I have shown you. Okay, we only have a minute. I just want to say something, and that is that there are other chemicals which you need to know about. I will deal with these next week, but they are actually quite simple. For instance, number 1 and number 2 is one area, and all of 3, 4, 5, 6, 7, 8 is part of another area. Detergents, there is on this PowerPoint, which I will send you, this, and there is also this. Okay, they are at the end of the whole presentation. It's all there. Okay. All right. So that's it, guys. That's basically the end of the lesson. I hope it was useful. If it was useful, great. If it wasn't useful, you don't need me. If you don't need me, that's fine. That's no problem. I'll just go and play with my fingers. I hope that Silver Spring, Genesis, MCO, Tumaini, if they ever listen to this, that you learn the simple points, okay? Just try to draw out that, alkene to alkane, alkene to alkanol to alkanoic acid to ester. Keep on drawing it out. Soon it will fit in your mind. It will be in there forever. When you are my age, you will be going, I can still remember that. Useless at that point, okay? So I will send to I have already sent to your supervisors, 1, what we have done today, 2, some questions, two sets of questions, and tomorrow I will have written out the answers and I will send you all of the answers so you can look at them yourselves, okay? You have been very patient. You are brilliant students. I really, really mean it. Very, very good. Now go and run the train stations, the bus stations, the restaurants, the clubs, everything. Your country needs you, okay? I'm going to stop.